a clearing in the rainforest. Heat rises from the canopy, thick with the smell of wet earth. The silence breaks. Something shifts near the river's edge. A flash of green, a ripple of still water. For an instant, the forest holds its breath. Then, impact. Small feet strike the surface again and again, faster than the eye can register. Each step sends droplets flying in chaotic halos. But the body above does not sink. The creature moves as if the river has turned solid beneath it, sprinting across liquid glass. In seconds, it vanishes into the jungle. The predator pursuing it stops short at the bank, powerless, as if it has just witnessed a miracle. But what we've seen is no illusion. It is an animal turning water into a road, and no one is entirely sure how evolution made this possible. For centuries, local people have told stories of this river ghost, a reptile that refuses the rules gravity imposes on every other body. Scientists gave it a name, but nicknames proved harder to erase. Jesus lizard, the reptile that walks on water. In fact, it runs. And to understand how, we must first return to the place it calls home. The basilisk lizard lives in Central and South America, in dense rainforests, where rivers are both barrier and lifeline. In this world, predators strike from every angle. Raptors from above, snakes from below, mammals along the banks. To survive, a creature must find an escape route where no one expects it. For the basilisk, that path is the water itself. Its agility begins on land. Strong limbs allow it to sprint with startling acceleration. Long toes spread wide, each tipped with fringes of skin. When it enters a river, those same adaptations transform into something uncanny. In place of sinking, its steps beat the surface with such speed that the lizard generates tiny air pockets beneath its feet. Each impact acts like a miniature slap, creating lift before the water collapses back in. The result? A reptile running, not swimming, for distances of up to 20 meters before gravity finally claims its weight. To witness this is to see the impossible redefined by biomechanics. But here lies the twist. Surface tension alone cannot explain what is happening. Water should yield, swallowing the animal instantly. And yet, with a burst of motion, the basilisk escapes its predators by using the river as an open highway. The paradox deepens when slowed down on high-speed cameras. In each fraction of a second, the lizard's foot punches downward, scooping water with enough force to counteract its body mass. Then, impossibly, it retracts before the collapse, rising again to strike in the next instant. Biologists have measured its stride at up to 20 steps per second. Movements so fast, they blur into one continuous defiance of physics. Even more mysterious, juveniles manage this feat better than adults, their lighter frames and higher speeds giving them the edge. The escape, then, is as much about timing as anatomy. Every fraction of hesitation means sinking, capture, death. Evolution has engineered not just strength, but precision. Scientists still debate the exact balance of forces that make this run possible. One hypothesis focuses on hydrodynamics, the idea that the foot's downward slap generates enough vertical force to keep the lizard aloft, while the curling toes scoop backward to propel it forward. Another theory emphasizes the role of air pockets. High-speed video reveals small cavities forming under the foot, trapping air just long enough to reduce drag and create temporary buoyancy. A third explanation is rooted in energy transfer. By keeping its stride frequency just above a critical threshold, the basilisk maintains momentum faster than gravity can pull it under, sustaining motion on the surface until exhaustion or distance provide safety. Each of these theories illuminates part of the puzzle, but none can fully explain why the basilisk can sustain its run while no other reptile comes close. The mystery deepens when compared to other species. Insects like water striders use surface tension to skate across ponds, but they weigh almost nothing. Birds can slap their wings on water briefly, but never to cross full rivers. Frogs leap but sink. No other vertebrate has mastered this balancing act of mass, speed, and physics. The basilisk alone seems to have rewritten what we thought we knew about locomotion in the natural world. Perhaps its mastery is not in a single trait, but in the synergy of many: limb speed, toe fringes, body posture, and a nervous system tuned to impossible reflexes. In the rainforest, that synergy becomes survival. A jaguar or snake lunges, and the basilisk is already gone, sprinting on water toward a vanishing point. The predator is left staring, bewildered, while the prey becomes untraceable. What remains is the haunting provocation. How did evolution engineer such a phenomenon? To turn liquid into solid, fear into escape, biology into miracle? The basilisk lizard does not stop to answer. It runs, vanishes, and leaves the question behind. Scientists measure, model, debate. Yet the river keeps its secret. For those who glimpse it, the sight lingers. A reptile defying gravity, sprinting across the impossible, rewriting the boundary between land and water. The creature that walks on water still leaves us wondering. How can an animal transform fluid into freedom? And why has no other species followed its path?